What if the Milky Way and Andromeda galaxies collided? In the vast universe, where galaxies drift like massive specks of dust in the endless void, a great cosmic collision is gradually taking shape. The Milky Way, our home galaxy, and Andromeda, a colossal neighbor 2.5 million light-years away, are on an inevitable course. A dramatic cosmic encounter set to unfold approximately 4.5 billion years from now. But what will happen when these two enormous galaxies collide? Will there be a cataclysmic cosmic explosion that disrupts everything? Or will it be a magnificent merger, giving birth to an entirely new galaxy? Will our solar system be swept into the chaos? Or will it remain safe amidst the unfamiliar celestial landscape? Let's explore the grand scenario of one of the most extraordinary astronomical events in the history of the universe, the merger of the Milky Way and Andromeda. A cosmic dance of galaxies. The universe is a vast stage where galaxies are in constant motion, spinning in an endless gravitational dance. In about 4.5 billion years, our Milky Way and Andromeda, the largest spiral galaxy in the local group, will engage in a spectacular cosmic performance, a galactic merger. However, unlike the fiery collisions often depicted in science fiction, this process will be slow and awe-inspiring, unfolding over billions of years. How will the galaxies consume each other? As the two galaxies approach one another, their immense gravitational forces will begin to distort their shapes. The elegant spiral arms of the Milky Way and Andromeda will stretch and elongate, forming long streams of cosmic matter, like interstellar ribbons. Contrary to what one might expect, the stars within these galaxies will rarely collide directly, as the distances between them are vast. Instead, their orbits will be disrupted, leading to a large-scale rearrangement. Under the influence of gravity, both galaxies will perform multiple gravitational dances, passing through each other, stretching apart, and then being pulled back together. With each encounter, they will lose kinetic energy and gradually merge. This process may take about 2 billion years, after which the two galaxies will fully unite into one. The birth of Milkomeda, a new galaxy. Following this grand galactic merger, a new galaxy will emerge, possibly named Milkomeda or Milkdromeda. Unlike the spiral shapes of the Milky Way and Andromeda, the new galaxy will likely take on a massive elliptical form, similar to many other merged galaxies observed by astronomers. At this stage, the center of Milkomeda will shine brighter than ever. The supermassive black holes at the cores of both galaxies, Sagittarius A of the Milky Way and the supermassive black hole of Andromeda, will gradually orbit each other until they eventually merge, forming an even larger black hole with unprecedented gravitational strength. When this happens, the collision of these black holes may release powerful gravitational waves, rippling through space like waves spreading across a pond after a stone is dropped. A new era in the universe. After the merger of the Milky Way and Andromeda, the night sky of Earth, if life still exists by then, will be entirely transformed. If humans still inhabit the planet and look up at the sky, they will witness a breathtaking celestial panorama, with a vast luminous band where the remnants of Andromeda and the Milky Way continue to blend together. In summary, rather than a catastrophic collision, this merger will be a cosmic rebirth, creating a new galaxy, Milkomeda, where life may continue to exist and evolve. This is not the end of the Milky Way but rather the beginning of a new chapter in the grand story of the universe. The dance of the stars. When we look at the night sky, the stars appear as static, twinkling points of light, but in reality, they are not motionless. They are hurtling through space at hundreds of kilometers per second in a cosmic dance that spans billions of years. And when the Milky Way and Andromeda collide, this dance will change forever. Although both galaxies contain hundreds of billions of stars, the immense distances between them make direct star-to-star collisions extremely rare. If the Sun were the size of an orange, the nearest star, Proxima Centauri, would be about 3.000 kilometers, 1.860 miles, away. Instead of crashing into each other, the stars will primarily be affected by gravity, causing their orbits to shift dramatically. The gravitational stretching of galaxies. As the Milky Way and Andromeda draw near, each galaxy's gravitational pull will stretch and distort the other, forming long, tangled streams of matter stretching from one galaxy to the other. Star clusters will no longer retain their original positions, instead being flung into new, unpredictable orbits. During this process, some stars will be ejected from the galaxy, while others will move deeper into the merged galaxy. This phenomenon has been observed in other colliding galaxies, where streams of stars are torn from their parent galaxies, forming stellar currents drifting through intergalactic space. These stars, separated from their home, will wander the universe forever, no longer bound to any galaxy. Where will the solar system go? One crucial question is, will our Sun be safe? Currently, the Sun orbits the center of the Milky Way at a speed of approximately 828.000 kilometers per hour. As Andromeda approaches, its orbit may be altered, but the probability of the solar system being ejected from the galaxy is very low. Instead, the Sun is more likely to be pushed into a new position farther within the merged galaxy, Milkomeda, while continuing to orbit the new galactic center. However, once the merger is complete, one thing is certain: the night sky will never be the same. If humans are still on Earth at that time, they will witness a spectacular sight, a brilliant band of billions of new stars appearing in the sky, far brighter than the current Milky Way. Newly formed star clusters will create dazzling regions where young blue stars shine intensely. Other areas may fall into darkness if they are absorbed into the dusty and gaseous core of the new galaxy. The birth of new stars. One of the most significant consequences of the galactic merger is the explosion of star formation. When two galaxies merge, their vast clouds of gas will be compressed together. This will trigger a wave of new star births, producing bright and young stars much more luminous than our Sun. For hundreds of millions of years after the collision, Milkomeda will enter its golden age, filled with powerful, youthful blue stars. However, not all newly formed stars will have long lifespans. These massive, brilliant stars will quickly burn through their fuel and explode as supernovae, releasing enormous amounts of energy and creating heavy elements like gold, silver, and uranium, essential components for life and planet formation. What will the new galaxy look like? Once the merger process is complete, Milkomeda will no longer be a spiral galaxy like the Milky Way or Andromeda. Instead, the chaotic gravitational interactions will transform it into a giant elliptical galaxy, similar to the ancient galaxies astronomers have observed in the universe. At this point, the stars will no longer be arranged in a spiral pattern but will be randomly distributed in a massive spherical shape. The supermassive black hole at the center of Milkomeda will be more powerful than ever, potentially consuming surrounding matter and releasing high-energy radiation. The night sky of Milkomeda will be vastly different from what we know today, filled with brilliant star clusters but lacking the faint, misty band of the Milky Way we are familiar with. A cosmic dance, not a chaotic collision. When the Milky Way and Andromeda collide, the movement of stars will be dramatic but not as chaotic as one might imagine. Most stars will not collide directly, but their orbits will be significantly altered. Some stars may be ejected from the galaxy, becoming rogue stars wandering through the universe. The solar system is likely to move to a new position within the merged Milkomeda galaxy but will remain safe. A burst of star formation will occur, creating a generation of brilliant young stars before the galaxy gradually stabilizes. Rather than a destructive collision, this event will be a cosmic rebirth, where ancient stars are repositioned. New stars are born, and our galaxy enters a completely new chapter in its multi-billion-year journey. The invisible yet powerful laws of the universe. The universe operates under invisible but immensely powerful laws. As Andromeda and the Milky Way merge, what will be the fate of the solar system, and of Earth itself? Will we be consumed by the chaos of the cosmos? Or will we safely endure this grand transformation? Where will the solar system end up in Milkomeda? The Solar System currently resides in the outer disk of the Milky Way, about 27.000 light-years from the galactic center. As Andromeda approaches, gravitational forces will stretch and reshape the orbits of hundreds of billions of stars, including the Sun. Although there is no risk of the Solar System being pulled into the supermassive black hole at the core of the new galaxy, it may be pushed farther away. Astronomical simulations suggest that after the merger, the Sun could move to a position much farther from the center of Milky, possibly up to 100.000 light-years away. This means that we will become part of the outer regions of the newly formed galaxy. Will Earth be destroyed? Good news. There is no evidence that this collision will destroy Earth or the other planets in the Solar System. The reason is that the distances between stars are vast, making the probability of a rogue star entering the Solar System extremely low. However, a few scenarios could still occur. The chaotic gravitational forces could alter the Sun's orbit, causing it to move at a different speed than it does today. A wandering star could come closer to the Solar System than our current nearest star, Proxima Centauri. If this happens, its gravitational influence could disturb the Oort cloud, a distant region filled with comets, causing them to fall inward and trigger massive meteor showers lasting millions of years. Despite these changes, Earth will continue orbiting the Sun and life could still persist on our blue planet. How will the night sky change? Although Earth will remain safe, our night sky will look completely different. As the Milky Way and Andromeda merge, their iconic spiral structures will disappear, replaced by a massive elliptical galaxy with a brilliant glow stretching across the sky. Some significant changes in the night sky include: the Milky Way will vanish. If you've ever admired the faint glowing band of the Milky Way stretching across the sky, prepare to say goodbye to it. Once Milky forms, this spiral structure will be replaced by a more dispersed but much brighter field of stars. A brighter sky, due to the star formation burst after the collision. The night sky will be filled with young, hot blue stars that shine far brighter than what we see today. Familiar constellations will disappear. Constellations like Orion, Pegasus, and Ursa Major have remained recognizable for tens of thousands of years. However, as stars shift into new orbits within Milky, these familiar shapes will be distorted beyond recognition. Streaks of wandering stars, some stars, stretched by gravitational forces, will form faint, glowing streams across the sky, a phenomenon never before witnessed in human history. If humans still exist on Earth or on other planets by then, they will witness a spectacular night sky, vastly different from what our ancestors knew. The Solar System's place in the new galaxy. After billions of years, once Milky stabilizes, the Solar System will likely end up in the galaxy's outer regions, where light is dimmer and star formation has nearly ceased. This means the night sky will have fewer young, bright stars compared to the galactic core. The chaos of supernova explosions will no longer be a threat, making the cosmic environment around the Solar System more stable. Earth and the other planets will reside in an aging part of the galaxy, where stars like the Sun are gradually reaching the end of their lifespans. No matter where it moves, the Solar System will continue its journey through the universe, orbiting the center of Milky along a new trajectory. The Solar System will not be destroyed, but it may be pushed farther into the merged galaxy. Earth will still exist, but the night sky will be completely transformed. Constellations will disappear or become distorted, and familiar galaxies will no longer appear as they do today. Milky will be a massive elliptical galaxy, presenting a dramatically different cosmic landscape for future generations. This event is not an apocalypse but rather a rebirth of the galaxy, a new chapter in the universe's billions of years long story. The universe, a stage for cosmic spectacles. The universe is not just a cold, silent void. It is a vast stage where the most spectacular events unfold on a galactic scale. When the Milky Way and Andromeda collide, one of the most breathtaking consequences will be an unprecedented era of star formation. Collision. Not destruction, but creation. When we think of a galactic collision, we often imagine destruction and chaos. However, this event is not merely a cosmic battle between two giant galaxies, it is also a grand cosmic rebirth, where billions of new stars will be born. The primary reason for this starburst is the immense clouds of gas and dust within both galaxies. As the Milky Way and Andromeda draw closer, their enormous gas clouds will collide and compress under intense gravitational forces. This process will trigger star formation at rates tens or even hundreds of times higher than today. How will star formation explode? Currently, the Milky Way has star-forming regions such as the Orion Nebula and H2 regions scattered throughout its spiral arms. However, these regions form stars at a relatively stable pace. Once the collision occurs, this rate will skyrocket, and new, stellar factories will emerge across the newly merged galaxy. Milkomeda. The massive hydrogen clouds will rapidly collapse, increasing internal temperature and pressure, which accelerates nuclear fusion, leading to the birth of countless new stars of various sizes. Red dwarfs, the most common type. Long-lived but dim, sun-like stars, large enough to shine steadily for billions of years. Massive blue giants, the blazing torches of the universe, but also the shortest-lived stars. Simulations suggest that within just a few 100 million years after the merger, the star formation rate will peak, potentially producing hundreds of billions of new stars. Blazing candles, the explosion of supernovae. However, where there is birth, there is also death. The massive stars born during this era will not last long. Some may be tens or even hundreds of times the size of the Sun. But their lifespan is only a few million years. Once their fuel is depleted, these giant stars will end their lives in supernova explosions, cosmic blasts so powerful that they can outshine an entire galaxy for weeks. The effects of supernova explosions. Massive shock waves. Supernovae release tremendous energy, sending shock waves through the galaxy, compressing nearby gas clouds, and triggering the formation of new stars. Dispersal of heavy elements. These explosions scatter heavy elements like iron, gold, and uranium, providing essential building blocks for rocky planets like Earth. Formation of black holes and neutron stars. If a star is massive enough, its core may collapse into a black hole or a neutron star, some of the most mysterious and powerful objects in the universe. During this period, Milkomeda will glow with the light of thousands of supernova explosions, creating a spectacle never before seen in cosmic history. Will the solar system be affected? A key question arises. Will these explosions pose a danger to Earth? The answer is no direct threat, but possible indirect effects. If a supernova occurs within 30 light-years of the solar system, its radiation could destroy Earth's ozone layer, increasing the risk of mass extinctions. However, since the solar system may be pushed farther away within Milkomeda, the chances of being near such an explosion are very low. Nevertheless, more intense cosmic rays from supernovae could affect Earth's climate and accelerate genetic mutations in living organisms. In short, Earth may witness a sky illuminated by supernovae, but it will not be destroyed by them. Milkomeda, a realm of stars. After several billion years, as the star formation rate slows down, Milkomeda will stabilize into a massive elliptical galaxy, filled with the remnants of countless supernova explosions. New generations of stars will replace the old ones, continuing to shine for billions of years. One day, stars born during this era may develop their own planetary systems, and perhaps a new civilization will gaze at their sky, wondering about their origins, just as we do today. The collision between the Milky Way and Andromeda will trigger a massive star-forming era. Colliding gas clouds will compress, producing hundreds of billions of new stars in Milkomeda. Massive stars will rapidly evolve and end in spectacular supernova explosions. The solar system will likely remain safe but witness a sky filled with supernovae. Milkomeda will shine brilliantly for billions of years before settling into an aging elliptical galaxy. This collision is not just a cosmic battle, but a celebration of star birth, where life may continue to emerge amid the remnants of dying stars. A dance of giants, the fate of supermassive black holes. As the Milky Way and Andromeda drift closer, it's not just stars and nebulae that will be affected. The most powerful entities in each galaxy, their supermassive black holes, will also be drawn into an unstoppable gravitational dance. At the heart of the Milky Way lies a supermassive black hole known as Sagittarius A, SGRA*, with a mass of about 4.3 million times that of the Sun. Meanwhile, Andromeda harbors an even larger black hole, weighing around 100 million solar masses. When the two galaxies merge, these two black holes will spiral toward each other, orbiting in a gravitational waltz for millions of years before finally merging into an even larger supermassive black hole. Phase 1. The chase in the darkness. At the beginning, as the Milky Way and Andromeda start merging, their galactic centers remain tens of thousands of light-years apart. The two supermassive black holes will be drawn toward each other due to gravity. But they won't immediately collide. As the merging galaxy reaches a more stable phase, the two black holes will gradually move closer, spiraling inward along an ever-tightening orbit. During this phase, they will drag in vast amounts of gas, dust, and surrounding stars, forming brilliant accretion disks and ejecting jets of matter at nearly the speed of light. Phase 2. The dance of death. Gravitational waves ripple across the universe. As the distance between the two black holes shrinks to just a few light-years, they will orbit each other at incredible speeds, completing a full revolution in just days, or even hours. During this process, powerful gravitational waves will be emitted. These waves, detectable by observatories such as LIGO and Virgo, provide direct proof of Einstein's general theory of relativity. Effects of gravitational waves. These ripples in spacetime will travel across the universe at the speed of light, distorting distant galaxies as they pass. If an advanced civilization exists somewhere in the cosmos, they may detect the signal of this merger millions of years after it occurs. Phase 3. Collision and cosmic shock. When the two black holes are only a few 100,000 kilometers apart, they will finally merge into a single, colossal black hole, potentially weighing tens or even hundreds of millions of solar masses. This moment of fusion will unleash an immense burst of energy in the form of radiation and gravitational waves. If a civilization exists in Milky at that time, they might witness a spectacular flash of light from the galactic core, marking the birth of a new supermassive black hole. Consequences of the merger. The newly formed black hole will create an extremely bright galactic nucleus, emitting powerful X-rays and radio waves. Nearby stars could be torn apart by tidal forces, generating explosive bursts as their material falls into the black hole. Intense radiation may disrupt star formation in the surrounding region, slowing the birth of new planetary systems. Will the solar system be affected? Since the solar system is likely to be pushed farther from Milky's center during the galactic merger, we won't be directly affected by the collision of the two supermassive black holes. However, if we were still near the galactic core at that time, the powerful radiation and energy eruptions from the black hole merger could increase cosmic ray exposure, potentially impacting Earth's climate or ozone layer. The unified black hole, a milestone in galactic evolution. Once the merger is complete, Milky will become a galaxy with an extraordinarily bright core, home to a supermassive black hole that could weigh hundreds of millions of solar masses. This event will not only be one of the most violent collisions in the universe but also a crucial step in the evolution of galaxies. In the cosmos, every act of destruction paves the way for a new chapter in the formation of celestial bodies. Both the Milky Way and Andromeda have supermassive black holes at their centers. As the galaxies merge, these black holes will orbit each other before colliding. Their merger will generate powerful gravitational waves, spreading across the universe. A much larger black hole will form after the collision. The solar system is unlikely to be directly affected, though indirect consequences may arise. This merger will be a cosmic spectacle, an evolutionary milestone where massive black holes unite to create a stronger, more luminous galactic center than ever before. A grand cosmic event awaits. In about 4.5 billion years, an extraordinary cosmic event will take place. The Milky Way and Andromeda will collide to form a massive new galaxy, Milky. This process will not happen instantly but will unfold over billions of years, slowly yet powerfully reshaping the cosmos. Although this event will dramatically alter the appearance of the night sky, the solar system is expected to survive. However, the immense gravitational forces from the merging galaxies could push the Sun and its planets farther from the center of the new galaxy. This merger will trigger a burst of star formation, producing countless new stars, some of which will become massive and end their lives in dazzling supernova explosions. Meanwhile, the two supermassive black holes at the galactic centers will gradually draw together, ultimately merging in a tremendous gravitational shockwave. While this is a grand event, it unfolds on a timescale of billions of years, meaning there is no immediate threat to life on Earth. However, if an intelligent civilization exists in the distant future, they will witness the most spectacular cosmic dance in the history of our galaxy. The collision between the Milky Way and Andromeda is not a cataclysmic disaster but rather a new chapter in the universe's evolutionary journey. Over the next billions of years, the night sky as we know it will be completely transformed, unveiling a vast and magnificent new galactic landscape. This reminds us that the universe is always in motion, constantly changing and evolving. The merger of these two galaxies is a testament to this natural law. Everything has a beginning, a transformation, and an end, but from that, something new will be born. What do you think about this grand cosmic event? Will humanity still exist to witness the moment of unification? Share your thoughts in the comments below. If you found this content interesting, don't forget to like and share so more people can explore the mysteries of the universe.